Hi, everybody. This is my dog, Grace. Say hi, Grace. Good dog. Okay. All right. So there was a request to do an integration by parts problem when we have sort of a messy argument. And so what I'm going to tell you to do is we're going to do a U substitution to get this component out. That was Grace. We're going to get this U component out and make it a little less ugly in the argument, because that's creating some issues for some people. So I'm going to use this cursive U with a 1 underneath it so that when we do our U and our dv, it doesn't get confused. So I'm going to have this cursive U1 equal to negative 9t. And we are going to solve for t, so we can take care of that t there. And so t is equal to cursive U1 multiplied by 1 over negative 9. I take the derivatives, and I get negative 1/9 d cursive U1 is equal to dt. So this transforms to negative the integral of 1 over 9 times 8 cursive U1 cosine cursive U1 d cursive U1. So after we simplified this, it really looks like negative 8/9 the integral of cursive U1 cosine cursive U1 d cursive U1. So now we're going to let U be this part. And then we're going to let dv be this part. And so I wrote that down here and here, and I ran out of space, but just trust me, that's the cosine part there, okay? Oops, I forgot the cursive part there. So U is that, and dv is that. So U is du1, and then we integrate this, so we have sine U. So now we're going to do negative 8/9 the integral of U1 cosine U1 du, and then that's equal to negative 8/9. I forgot it initially, so I had to put parentheses around this and then put the negative 8/9 there, because that's coming from this negative 8/9. And I go uv, so I have cursive U1 sine U1 minus, and then it's v du. So I have the integral of sine U du. Okay, now we're going to take the antiderivative of sine, and we're going to get negative cosine cursive U1. And then that's just there. We put our plus c. Distribute our 8/9, make that a positive. So we have negative 8/9. And we grab up here, remember, our U is equal to our cursive U1 is equal to negative 9t. So we have this negative 9t and this 9 getting canceled, the negative and the negative making it a positive. So I have 8 sine the argument of negative 9t. And then this is a minus and a minus. So this becomes plus a negative 8/9, which is really minus 8/9. And then that's cosine negative 9t. And then it's plus c. And so that's our end result right there. Okay, let's show you the same idea with the natural log one. So we have x to the fourth, we have ln 3x dx. So we're going to let that u1 be the 3x. And we treat that x then as u1 over 3. So this is going to replace the x. And then we get our u in that space. So when I do this component, I get 1/3 du1. So there's my 1/3. There's my du1. I get my ln u1. But then this piece, u1 over 3, replaces the x there. So I have u1 over 3 to the 4th power. So I have u1 to the 4th, and I have 1 over 3 to the 4th coming out of this expression. And then I have the 1/3 times the 1/3 to the 4th. All right, well, that's really 1 over 3 raised to the 5th power. I have u1 to the 4th, ln u1. And so by LIAT, remember our LIAT thing, the LIATE, logarithm, make the u. Okay, so dv is going to be this u1 to the 4th power du1. I drop my 1 there. And then I take the derivative, I get 1 over u1, and then I integrate this, so I get u1 to the 5th over 5. I have 1 over 3 to the 5th, and I'll have 1 over 3 to the 5th because of that's in front. I'm going to take u, v, and so I put the u1 to the 5th over 5, ln u right there, minus v du. So I end up with u1 to the 5th over 5 times 1 over u1. Well, those cancel, leaving me with u1 to the 4th. And that's reasonably nice to take the antiderivative of. Okay, so we follow through the process. I'll just leave it here for a second. You can take a look. But at the end, we go back and we grab the 3x from the top, and we put the 3x, the 3x, the 3x, and then we end up with the plus c. You'll have some fun with the large values that are coming out of 3 to the 5th times 5, and that's about it.